Here guys, I just opened the tape loading mechanism. It's just 2 screws, one here and one here. Alright, it assembles like that. As you may see, springs are in much better condition than on my 7000, and they are tougher. My spring here was like extended and it was not pushing that much, but it still works. Alright, and now I need to remove this big gear to replace the belt, so stay tuned. Okay, I removed the gear. It just pops up with this simple mechanism, and I had to remove another one to install belt because it just don't fit between metal plate and the pulley. I tested both belts. One is too thin and too long, other is too short from the set from this guy, and I using my belt, which is thick and correct length. You see, it's larger than pulley. The one I tried, like it barely fits onto the pulley with no room, like it will be too tight. Alright, now I will install it back and assemble. See you in a moment. And that's how looks assembled mechanics. And the pin from this black plastic lever should get into the directional inside the gear, and when you rotate it, it will move this lever. I tried to show you with one hand, so you see it's moving one direction and it's moving opposite direction when the gear rotates, right? That's how it should look like and work. And now we have to assemble these 2 pins, metal pins, from the pushing mechanism to get inside these directions. Alright, and the outside part here, as you remember, it will be pushing this lever here. So we need to get 3 pins aligned, and I will be pushing like that to get it in and settle the gears in place. See you in a moment. That is how full assembled mechanism looks, and it should work. It's full extended position, and it pulls in and then pushes this lever up with the spring. Alright, see. Okay, I put back the door loading mechanism, and here I will be replacing the switches, and as promised, so here's the DGK part number codes for both of them, so you would be able to find them. Okay, see you. And voila, no switches installed, and they would be able to work like that. You see, one side, and when this will extract, it will switch on the other side. And as you may see, I started assembling. I put this top lever, it goes in between these 2 cheeks and on the shaft here, and it's exactly like I told you when I was trying to guess how to assemble 7000. So it works like that. Okay, so moving on, next would be this part. Install it into this position here, this here, and then like on the right side we will complete with this part, which has 3 pins. One gets into this lever here and 2 goes into this scissor mechanism on the right side. Alright, not complex. So like that design, like I've seen on Sony 777, right? So scissor mechanism, and when you remove the door, like you can work on it. However, assembling is a little bit tricky and requires some patience. All right, now I need to extract fully door, because to assemble everything you would need to make it happen. Like we need to install it on full extracted position. All right, see you in a moment. All right, and now when the door mechanism is assembled, You see it can move. I will rotate to validate that everything closes properly, and you see stabilizer is being pushed as needed. Again, open, close. Then the last step left is to put back these wires, and we will be done. See you in a moment. All right, now wires solder it, put them into this little hole here in the board so we have flat surface. When we will cover with the metal plate, it will not harm any wires. Okay, and these wires connected together in this position. All right, and we tie it here. So we should be good now. Don't forget to solder your door opening motor with blue wire in the inside and yellow wire outside. Now I will put it back and let's see how everything will perform. See you soon. All right, everything assembled. It's not fully operates correctly. A door opening requires assistance. It's kind of like tough, but closing works. Tape stabilizer works. Everything else works. Nice and quick and easy. So I would need to like disassemble tape transport out of the deck one more time and see what's getting tough in the door opening mechanism. So far everything was assembled correctly and I was validating with my hand. Maybe like the screws went from the bottom, they make it stiff, like, and some are like it's my play a little bit. I'm not sure. I would need to check. Tape. And nothing. Oh, finally we have something on tape. That's a good sign. But levels, why so low? All right, let me see what else. I'm so sorry. I'm just like installed tape in the reverse side where just like white noise was recorded, and that's where like I tried to hear and I don't hear music, right? Just white noise, right? You hear now it plays. So that's where I have to validate what's wrong with the tape loading mechanism, why it's so stiff, like it should be easy moving. And then we will come to electronics validation and tuning. Deck sounds really nice, so stay tuned. Hey guys, the problem with opening and closing comes from the control board. For closing it provides 5 volts and for opening 3.5 volts, which definitely not enough for this motor to drive it. So even like a little bit of, you see 3.6 volts, 3.8 volts for opening. A little bit of assistance helps. And closing is more than 5 volts, so that's why it's closing. Alright, I need to find out what's wrong. Like I saw that mechanics, I lubricated everything. It's pretty easy. Goes with the hand now, like, but it still don't work. And like then I start measuring voltage, and 3 volts it is definitely not enough. It should be 6 volts. See. Alright guys, I'm looking more, and as you may see here, that the voltage reference for the control logic of this motor, it's 4.1 volts and 5.8 volts for open and close. And like as it goes to this driver, this will be the reference voltage for the driver, and I believe like it will also lose 0.6 volts approximately on the transistor, and will be driving like with exactly voltages I show you. But the motor aged, and I don't believe it can be driven now properly with the voltage. I just like barely touch it and it goes. Like it just needs a little bit of help. So I will be replacing this R909 resistor 2.2 kilo ohm with 5 kilo ohm pot, and we will adjust it a little bit higher, so probably like half volt higher, to make sure that it will open and close properly. Because motor is aged and like I don't believe it's work with required power. It's not hard now, like I can like just turn the wheel easily with my hand. So there is no that force, like I just, you see, just like rotate the wheel with my finger and everything works. Right, so let me try this trick, and if it will work, that would be nice. Well guys, I decided to experiment more, and I believe that I tested the motor. I applied like 3.5 and 4 volts, and it's definitely a 3-volt motor, so we would not be increasing the voltage on it, because like I measured consumption, and like it's really gets tough for him to work at 4 volts. So, and here I remember the spring which was like stretched right on 7000, and I believe that spring is culprit. It sits between this lever and this hole and ties together, and when DAC tries to open, right, that's where it cannot overcome the power of the spring. It's just like how it works. So let me install it and I will show you what's happening. And I believe like that's the point why it was stretched on the other DAC. Probably it was in service somewhere in Japan, I don't know. Or maybe some other guy was working and it was already serviced before. But I believe that's the culprit. Let me show you. All right, I'm installing the spring back. And now see, when I open the door, this spring have to stretch, and it's quite powerful spring, and that's where like it gives additional resistance. So it stops exactly, motor stops when it has to pull it to stretch. Okay, and that's where like there is no resistance, then the resistance comes and motor stops, and then after it's stretched, it's goes further without additional force. Let me play. I will try to install different spring and see how it works before stretching that one. Alright, to test the theory, I'm installing more lightweight spring, right? It's still like pretty good and like made from thick metal, so but I hope it will give less efforts to push. I believe that's the spring which defines the force, how it pushes the tape stabilizer, how hard. And initially it's 1.5 kilograms, but I don't believe it can work now well like that. Let me test it, see in a moment. The original spring is still intact, it's right here. Right, looks my theory was correct, so I can install the tape and I can eject the tape. Alright, and I want with this spring eject is not as quick as I would love to. So aged motor, like whenever it's happening, but it is what it is. Alright, so I can install it, it works, I can play it, like everything else works pretty fine. But this mechanism, yeah, I wish they installed more powerful motor for that. You see, it takes time to overcome all the resistance. And everything is lubricated, like I just don't know what else I can do. I will play more, a little bit more with this tape transfer to see if I can do it better. Maybe it just needs more workout. It was sitting for years. Who knows? Alright everyone, I decided to disassemble this motor. What I see that contacts are heavily oxidized. See, those are like has a dark color on it. Let me try it deoxidize and see if it starts working normally, or like I would need to think on more ideas. See you soon. Alright, and after all, it didn't help much. So you may see on opening we have 3.7 volts, and it's pretty like slow. Closing is 5.5 volts, and it's quicker. I don't know what I've been thinking about putting that like 3-volt motor on this heavy mechanism with like 1.5 kilogram force. Really, sorry guys, but I'm not impressed. Well, I was thinking more, and I remember that I had ordered similar motors like a couple years ago from China. I just tested it, works perfectly well on 3 volts. So I will be trying to install this guy. I don't understand the number in R341. Alright, and see if it will go, because like I feel torque with my finger here on 3 volts is way better. See you soon. Alright, I've installed the new motor, so that was disassembled as you may see. And I will like put back the original spring, so that's a stretch top spring. And even if it's closed, super nice. It still struggles to open. I need to help a little bit with my finger. At this point I'm very not sure what's going on. It should have enough power to open the door, and it needs to stretch the spring. So should I replace this resistor and add a little bit more voltage? That's the only way I see, because I can. Again, you see it closes really well, but open like it's really weak. Maybe this microchip is not giving enough power. It should give current. It controls 2 motors, real motor and this motor. Okay, let's see. Well guys, I found one more issue. I disassembled again, and I don't see spring between these 2 parts, and I don't recap it was there when I was disassembling. So maybe this is the root cause why it stops early or whenever, because this lever is pushing on the off switch, and it may play not in time, because I check it everything else. It should work. So there is like power transformation like from motor to here like about 10 times, and from here to here another 100 times. So it's kind of like should have a really strong force, but it just don't use it, and I just struggling to understand why. So let me try to install the spring and see if it will start work better. See you soon. Alright, I have found and installed the spring here. You may see how it works now. It should not be a powerful spring because the force here is minimal, but it should put lever in the proper position so it would not be pushing on the micro switch, because micro switch is super sensitive. It's very light. Alright, let me assemble. Let's see if it will start working now. Hey guys, at this point I'm starting to hate Aiwa designs. Imagine like these 2 springs give overall force like couple kilograms. I barely can push it with my hand, so hard it is. And they going to pull it with this motor, right, before they open the door. That's insane. Alright, now I need to catch up the whole again. Like all these parts don't play together well. Really, I'm not happy. Let's see how it will work. Hello everyone. I'm doing little progress. So what I did, I disassembled everything back and was playing with 3 volts on this motor to see how everything performed. And I come up that the small gear had residue from the old lubricant still on the shaft, so I clean it up, then clean it another one, then like was looking for different belts plate unless it started to work smoothly from 3 volts and capable to rotate end to end without any delays, stops and so on. I'm not sure if I would be able to do it with one hand, but believe me, now it started to work smoothly. And when I started from 3 volts, it was not capable to run both gears without everything else. Like it was like struggling. 3 volts was like too low for it. So that's where like 5 volts on the door closing was enough, but 3 volts on door open was not enough to move everything smoothly. I just pop up the gear. I need to set it back. But let's try one more time. I will assemble and like just see from the power supply if it will start working. See you soon. All right, everyone. Finally, 3.5 volts, and it can do full cycle easily to the end. It's open now. It's my learn, but I share my experience. The issue was with the shafts for both gears. That needs to be extremely well cleaned and relooped, and like I cleaned the holes in the gears, so make sure that they work smoothly. So, and I put back the original strong spring and it still works. All right. So I hope this knowledge will help with your research when you will be restoring your DACs. See you. Hello everyone. I'm happy to tell you that I'm finally won in this battle. It's 3 p.m. 6.5 hours. Okay, now let's see with the tape. It always closes quite without tape, with tape. Oh yeah, 1.5 kilograms. With original spring, everything works. Woohoo. That's the stretch spring which I didn't install and installed original finally. Nice. Whew. Long day. See you. Okay guys, it's next day. I'm continue tuning this DAC, and what I mentioned when I started recording, I mentioned that the bias was too low, like 3 to 4 decibel. And when I'm adjusted the bias, I'm observing the bump up to 1.5 decibel in the vocal range. So this means that heads are not reproduce enough high frequencies anymore. Even if I was loading my tape and it was more or less fine, I believe a little bit of compensation is needed. So I will install maybe 100 picofarad in a parallel to the head, playback head, to compensate for the loss and make sure this DAC still will be performing for the next 5-10 years. All right. Maybe it was Dolby. Let's test again. All right. That's 400 Hz and minus 23 decibel. Technically, we should be good. Like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we good. The azimuth, recording azimuth is a poo. 11, 12, 13, 14, 15, 16, 17. Let's see, it's dropping like. It's still recording, but it's not that good as I would expect. Right, and you see a little bump around like 2-3 kilohertz, 4-5 on the left channel. Maybe not that bad, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now we're closer. Without Dolby, it's about like right channel is fine and left like up to 0.8 decibel. With Dolby, everything changes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, you see. That was I not like very much. Let's see Dolby C. 1, 2, 3, 4, 5, 2 decibel. Oh my. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Like with Dolby, I don't see enough high frequencies. Dolby S still shows the same. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh my. Alright, I need to see if I can fix this behavior. See you soon. Alright, I'm playing back my Chrome tape recorded, I believe, on Sony, and frequency sweep is 400 Hz, 3 kHz, 5, 7, 8, 10. You see, minus 1.5, 2 decibel, 12, 13, 15. Yeah, that's the loss from the head. Alright, and no Dolby, as you may see. Let me compensate and let's see how it will behave. Alright, technically it's fixed. 100 picofarads fixes the issue. Alright, let me rewind it a bit more. It's now relatively flat on playback. There's almost no drop up to 20 kilohertz. Okay. Here we go. Azimuth is off, but I'm observing all levels. It's a little bit off. We are at minus 23 level, and it goes to almost straight. 6, 8, 10 kilohertz, no drop technically. 12, 15 starts to drop a little bit to go to 20. Alright, it should be good now. Let me adjust record and let's see how it will perform. Alright, I had to adjust playback level. I tested it, went 1 decibel up, and then I adjusted the bias, and now it's fully linear. So 1 kilohertz, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, minus 1 decibel, 17, 18. And it's much better levels now, you see. 20 kilohertz and type 1 tape and still recording. Out of phase, really. Pretty bad out of phase. I'm not sure what to do with that. It's aging of the heads, I believe, because like from all my experience, everything I have read, right, when we observe such big difference on the recording, this means that record head is not the same between left-right channel. We have to compensate on the bias perspective, and that makes this phase shift, because like magnetic field will be going differently, like mechanically through the tape surface. Okay, so but at this age we have what we have. It still sounds really nice, plays really nice. I should take back my words. So the only difference between 7000 and 9000 is this capacitors, this black one. In 9000 they put expensive film capacitors, 1 microfarad. 100 volts, right? And in 7000 it's just regular electrolytic capacitors, sits two back to back, and it's 22 microfarads, and they form like bipolar together. That's the difference. Sonically wise, this more linear, more like flat and relaxed. 7000 has like very juicy bass, like a really pushy, pumpy, and so on. That makes all the difference, and I can explain why now. Like I spent lots of time researching, and like what is happening. We have to put the big capacitor, which will push all frequencies to the load, right? And we have load with impedance, and this impedance will aid frequencies. If we put too small capacitor for impedance, we will not get low frequencies going through, or like phase shift on the low frequencies will be big enough like to muffle them. They would not be like sounding precise, pushy, like really live and active. From the other perspective, the bigger capacitors we put, the more induction and ESR it has, and it will start eating the high frequencies. So the good balance is always needed between capacitor size and impedance, and like to balance everything through the full DAC tracts, because there are so many stages, so many capacitors, they have to do big work. I don't believe they were calculating everything. They were just like trying out like different setups and just compare one to other, like what sounds the best and so on. So why 1 microfarad film capacitor? Because they're super expensive. At this time, like even 1 microfarad was very expensive, like $10 maybe. That's where like in mass production, that's matter. That's and 10 microfarad would be much bigger in size. So they were like trying to compensate. I have heard, I have compared so many setups, even with film capacitors. You know, I have 4.7, 10 microfarad, 7, like, and like I was comparing. So the schematic in the Nakamichi Dragon and RX 505 is technically the same. The only difference, RX 505 has 10 microfarad on the Dolby decoder output, which Nakamichi Dragon doesn't have. And for me, like RX 505 sounds more juicy, more interesting, like, and I can listen it for longer time. That was my biggest complaint for the X series and the Dragon. So they are too analytical, I would say, right? The 7000 sounds very juicy. Sometimes like you just feel it. It's maybe even too much. But it is what it is. Like if you read through the forums, that's what they do, right? They read, oh, we like 7,000 sounds better than 9,000. But again, like it's a matter of taste, right? And it's a matter of two capacitors replacement. You may make this 9,000 sound like 7,000. You just replace those two capacitors with one bipolar 10 microfarad, bam, you have it, all right? So moving on, we're almost at the finish line. I would also need to validate the DAC that it works and tune up chrome metal, validate all mods, tune up the calibration unit, and we should be good pretty soon. See ya. Hey guys, I'm still struggling with this DAC with recording. Playback is perfect, so as you may see, from 400 Hz to 15 kHz, so there is like zero change from the sample tape from Sony KS7. Alright, so it's perfectly fine, and it's my chrome tape, so it's not deteriorate quickly. But I cannot understand why it's recorded so poorly. Really. Let's try one more time. TDK recording azimuth is terrible. Yeah, that's what we have at 11 kilohertz. So at 1 kilohertz recording azimuth is really bad. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and it's dropping on the levels. I'm not sure what to do at this point. See you. Hey guys, I never did it before. I just turned it on React mode to check the phase of the bias which just there on the board sent to the record head, and I just puzzled. That's exactly what we are observing on our recording, and this suggests me only one thing, that one of the capacitors went bad. Now I will have to check schematic and see what capacitors I need to replace, because that should not be so. It should be going from the same generator, right? With HX Pro, it should have 2 coils, and we have it right there. See those 2 coils in the center of the screen. They should be coming from a HX Pro chip, but I don't see a HX Pro chip here. So I need to investigate more where it is and how to overcome it. But at least we know reason now. It's not mechanical, it's not the heads. That's problem comes from a HX Pro chip. That's the first research ever I did this way. When if you've seen multiple DACs with a similar issue, when phase is not aligned. But that's the first time when I really found that it's not the heads. Okay, see you. Continue my research. Okay, everyone, I continue my measurements, and what I came to, you see these 2 capacitors, they get signal from the rise head generator, and it's doubled in frequency because it uses 2 diodes to produce doubled frequency, and then it gets to this transistor, and on the first pin of the coil, the phase between left and right channel is fully matched, all right? But exactly on the pin 6, it's already out of phase significantly, and I see here 1000 polypropylene capacitor, which probably a culprit, because then we have 1.5 kilo ohm, which should delimit how significantly the next capacitor will affect. So I will start from replacing these 1000 picofarad capacitors and see how it will behave. See you soon. All right, I replaced these 2 orange guys for 1000 picofarad with brand new tamed 1000 picofarad 5% tolerance, and I just cannot understand and cannot explain. So what's happened, currently they are exactly in opposite phase, right? So there is no shift, they just in opposite phase. And I'm looking into the board, see this transistor and this transistor, right? And they connected to the opposite, so the coil between first and third elements, right? And here is the first and third pin here, and they connected this one to the first pin as in schematic, and this one to the third pin, so technically reversing the direction of the wave, all right? And that's where on the outputs are the same, so they are not reversed. And that's where we have exactly opposite reverse bias signal for left and right channel. So there is no any way I have to cut the traces and decouple and put the way so they will both work in the same direction. I don't have any other idea, so if you have, let me know. But I believe they made it for convenience of design. So you see this trace goes to the pin 3, and pin 3 is directly connected to pin 4, or to pin 1, like on the opposite coil. All right, but this makes like the coils are fully identical. They like usually wind in the same order and so on in one direction. For this design to work, coils needs to work in the opposite direction. Maybe it's supposed to be like that, but then they have to install different coils. All right, let me see if there are any markings on the coils, and like if they just like install it two coils of the same kind, or whenever it's happening. Hey guys, I tried technically everything, right? And to maintain the phase, I have to significantly disbalance the bias. I see now 1 kilohertz, 2, 3, 4, 5, but even if you're maintaining the phase, you see the levels are dropping to the right channel. So definitely, I tried to reverse phase between left to right. It didn't help. It just shifts on the opposite side. Like whenever I do, the only thing is to disbalance the bias, which helps with keeping the phase. All right, you see? So that's how far they go, and then they like almost coexist. That's only with bias. Right, so something is wrong with one channel, with the head, I believe. I'm not sure at this point. Research takes too much time. Alright everyone, so I tested everything. I thought more about the bias issue. So technically bias is bias waves are way shorter than sound waves, so like they still like multiple waves for the regular sound. So even if you reverse waves, so it wouldn't help, right? And I tried, I reversed it and put it back, and nothing changes. At this moment, like I give up battle for the record phase, because it's technically, I believe it's issue with the record head. It's rather degraded over time. It's not that worn to be that bad, but I just cannot overcome it, right? Anyway, I'm currently recording source tape, so that's the source, and sound is really good. Recorded sound is like listening the headphones, it's the same, no difference there. Probably I need to find some quicker song so you can hear at least a little bit of the sound. Let's go with this one. So technically there is no difference. It records well, so the only thing is phase, but I was discussing before, measuring this difference on the wave will come up as like 8 millimeter difference between distance between left and right speaker. So it's technically nothing to talk about. All right, I want to feel be a little bit not in phase, you would not be able to hear it. All right, so we get nice DAC which is tuned now. I will close it and test embedded DAC player. See you in a moment. Okay, and here I'm assembling the embedded DAC and testing with coaxial cable from my tablet. And recording, I tested all tape types and all the Dolby noise reduction system. So see here DAC direct. That's the line input, that's the DAC. Alright. Source, tape. So there is no difference with all Dolby types. And what is I mentioned, comparing to the modern DACs like this 2i2 DAC from not Fortnite, Focusrite. And these modern DACs, they are tuned for higher resolution, higher frequencies, that sometimes filtering may be not that good. and that's why, like, if I record with Dolby B and C from this DAC, it's frequently mutes the Dolby tracking, right? I need to use MPX to make Dolby tracking work properly. Dolby S works better, so it don't have this issue. You don't see it. All right, so I'm glad to say that this DAC is restored as good as it could be, right? So sonically, difference almost not possible to hear. This phase, as I told you, like it's mean like that one of the speakers is like 8 millimeter closer to you. Come on, you never do it that precise, right? So glad that this restoration finally come up with good results. Wow flutter is very low. Like I think I didn't measure yet, but sonically, like on oscilloscope, the wave is super stable. So there is no movement, no jumping. Like listening to the signal, like it's very good. My understanding is somewhere like 0.04 to 0.05, maybe less. All right, so that's as good as it could be. Thanks for your time, thanks for your attention. I will close it. If you will ask, well, I probably do comparison video to compare sound from this DAC and 7000 series. All right, 7000 like more basses than this one, but it's still like good enough for bass. Probably not that bassy. All right, it was a long video, but get me, well, like it's been like multiple days I was working on this DAC just to restore it, and like one day for the tape transfer, one day for the eject mechanism, and one day like to fight all these issues. It's a lot of time, so bear with me for more videos coming. I have more work to do. Hope you will like it. See you and bye-bye. Here would be the bonus part of this video. I'm assembled everything, measuring wow and flutter. As I told you, it's about 0.04, and it's even better, 0.035 to 38. But I mentioned that frequency is way too high. I mean, like I have to open it again and adjust the frequency on the motor. Oh my. All right. See you guys.